Hey, this is our next lesson on symmetry, on our first one on chapter 1, and we're going to go over 3 types of symmetry we're going to run into really quick. The first one is going to be even symmetry. The next one is odd symmetry. Last one is symmetry across the x-axis. If you notice, even symmetry has symmetry across the y-axis, and odd symmetry has symmetry we call across the origin, where the origin is 0, 0. You can notice graphically pretty easily the symmetry if I just look at a couple points. So on the even symmetry, I'm going to take a look at point, we'll call this 1, 2, 0, and then we notice that we have a symmetry point at -2, 0. So notice that it's my x values, change signs. So if I have a comma b, then if I have x-axis symmetry, I'm going to have -a comma b. I mean even symmetry across the y-axis. Okay, the next thing is for an even function. If I plug in -x to the original function, I output f of x. So I'm going to do a quick example right above here. Let's take an even function. F of x is equal to x squared. If I plug in a -x into that function wherever I see an x, notice when I square -x squared, get back the original equation. If that happens, then we know that that's an even function. Okay, an odd function, let's take a couple points here. Let's call this one 2, 2. And if this is an odd function, this point is going to be -2, -2. So if I go a comma b, then it's going to be -a comma -b. Okay, an odd function, if we do negative f of x, or let's just say if f of x is equal to x cubed, which is an odd function, if I plug negative f of x in, I'm going to plug that negative x in, it will output the opposite function. So as if I distribute a negative through the whole function. Okay, and so this one I'm kind of running out of room. So this one here would be f of x is equal to negative f of x. That would be an odd function. And an even function would be just f of x is equal to f. When you're done, you get the same exact function back. Symmetry across the x-axis. I'm going to pick, well, let's see, this one is 3, comma, 1, 2, 3, 4. And then this one is 3, comma, 1, 2, 3, 4, -4. And this one you're going to get, I have AB, and I have A, comma, negative. So my y values switch signs. However, it's not an even or odd function. So these are unique because we can test those algebraically. And we'll be doing that for homework. Okay. The next thing that we're going to look at is characteristics of graphs. We have x-intercepts. That's when you have a point 5, 0 is an example. This is where your y value is equal to 0. Your y-intercepts, and 0, 5. This is for your x values is equal to 0. Axis of symmetry is a linear line that cuts symmetric function into two equal parts. So if you notice back up here on this x-axis, this would be the axis of symmetry on C. It would be y equals 0, the symmetry line. If you notice below on the graph of this quadratic, I would have an axis of symmetry line that would go through x equals 0. I have x-intercepts at 1, 0. Actually, I think it's a 2. It's kind of hard to read. They're counting by 2's. So a 2, 0, and negative 2, 0. And then my y-intercept is going to be 0, negative, which is also my vertex. Okay. On some of these, we're going to be asked to graph by just plugging in a couple values. I looked at the square root function. Remember the square root function, this domain would be anywhere from 4 to infinity. So we're not allowed to be negative. So I'm going to start with my first value of 4. And 4 minus 4 is 0. Square root of 0 is 0. I'm going to be smart and pick the next perfect square, which would be 1. So I know 5 is going to work. 5 minus 4 is 1. Square root of 1 is 1. The next perfect square root is 4. So I know if I choose 8, 8 minus 4 is 4. Square root of 4 is 2. My next one is 9. So let's see, if I plug in 13, minus 4 is 9. Square root of 9 is 3. And my x values are getting way bigger than this graph, so I'm just going to stop there. And I'm going to put 4, 0, 5, 1, 8, 2. And I could go 9, and then 10, 11, 12, 13 if I wanted to, and just go up to 3. And there's my square root function. So once that after you do grasp, you're just going to do a table of values. You can use your calculator to help you. And then we're going to look at the standard form of a circle. Remember, a circle has two properties. It has a center. Well, it has a lot of properties, but these are the two we're going to look at. It's also got a radius. Okay. Standard form of a circle is x minus h squared plus y minus k squared is equal to r squared, where your center is the points h comma k, and your radius is just r. So my radius is being squared, and the coordinates of my center, when I put them into the equation, have the opposite signs. Okay, so when I write this problem out, this is my h, and this is my k. So I'm going to write my center, x minus 3 squared, notice they switch signs, plus y minus a negative 2, which changes it to a positive 2, squared is equal to the radius. Well, if I know the center is 3, negative 2, and I know a solution is somewhere almost here, and I want to find the radius, well, it's going to be the distance between those. So if I look, I can do the distance formula, which is the distance or the difference in my x values squared, negative 1 minus 1 squared, plus the distance in my y's, negative 2 minus 1 squared, and get 4 squared from this one, which is 16, get 3 squared plus is 9, get my distance is the square root of 25, which is 5, and I'm going to plug this into my equation, which is r squared So look over the homework. I have a feeling the hardest part is going to be testing for symmetry. There's some good examples in your book if you want to go back and look at them, or feel free to text me. Thanks.